Hi everyone, welcome to Target Teach Tutors. Today we will cover carbon chemistry, its properties, reactions, and importance in everyday life. We will dive into its role in fossil fuels, the science of combustion, and organic chemistry essentials. This lesson is packed with exam tips, so grab your notebooks and let's begin. I am going to present this lesson under the following headings: the basics of carbon, the role of carbon in fossil fuels, combustion reactions of carbon compounds, the role of carbon in organic chemistry by understanding the structure of carbon compounds, key environmental and practical considerations. First one, the basics of carbon. The key facts to know about carbon. Its atomic number is 6. It contains 6 electrons, 6 protons, and 6 neutrons. Its electron configuration is 2 and 4. That means it has 2 electrons in its first shell and 4 electrons in its outer shell. Carbon can form up to 4 covalent bonds, making it incredibly versatile. You can find the lesson on covalent bonds by clicking the link in the description below. Bonding and structures. Allotropes. Diamond. Each carbon atom is bonded to 4 others in a 3D lattice. It is used in cutting tools. Graphite. Each carbon atom is bonded to 3 others in flat layers. It conducts electricity and is used in pencils. Fluorines, hollow cages of carbon atoms. Example, Buckminster fluorines, C60. Exam tip for this section: be ready to compare the properties of diamond and graphite. For example, diamond, it is hard, doesn't conduct electricity. And graphite, it is soft, slippery, conducts electricity due to delocalized electrons. The second one is the role of carbon in fossil fuels. What are fossil fuels? Fossil fuels like coal, oil, and natural gas are formed from ancient plants and animals that decomposed under heat and pressure over millions of years. Now we'll consider about hydrocarbons. They are compounds made of carbon and hydrogen only. Fossil fuels are rich in hydrocarbons, alkanes. Its general formula is CnH2n plus 2, the products ending in ane, and can be identified as alkanes. For example, methane CH4, ethane C2H6, propane C3H8. To find the chemical formula of them, if N is 1, substitute 1 in CnH2n plus 2 formula. Give the product's chemical formula is C1H2 times 1 plus 2 is equal to CH4. Likewise, you can work out any formula for alkanes. Exam tips for this section: understand the environmental issues of fossil fuels such as global warming. Combustion produces carbon dioxide, it is a greenhouse gas. And acid rain. Burning fossil fuels release sulfur dioxide SO2, which reacts with water in the atmosphere forming acid rain. The third one, combustion reactions of carbon compounds. What is combustion? Combustion is a reaction of a substance with oxygen to produce energy. There are 2 types of combustion reactions that occur in hydrocarbons. First type is complete combustion. It occurs in the presence of plenty of oxygen. It produces carbon dioxide CO2 and water H2O and releases maximum energy. Example for this combustion: methane, when burned in oxygen, it shows in the form of word equation and symbolic equation. In the word equation, methane plus oxygen produces carbon dioxide plus water plus energy. Symbolic equation is CH4 plus 2O2 gives rise to CO2 plus 2H2O plus energy. It is very important to remember that when you are asked to write a symbolic equation in the exam, you must balance it. The second type is incomplete combustion. It occurs in the presence of limited oxygen supply. It produces carbon monoxide CO and or soot carbon and less energy. A word equation for this reaction is methane plus oxygen gives rise to carbon monoxide plus water plus energy, and the symbolic equation is 2CH4 plus 3O2 gives rise to 2CO plus 4H2O plus energy. Exam tip for this section: be prepared to explain why carbon monoxide is dangerous. It binds with hemoglobin in blood, reducing oxygen transport, and then what will happen? Give me your answers in the description below. Tip for the above question is: properties of carbon monoxide are colorless, odorless, and poisonous gas. The fourth one, the role of carbon in organic chemistry by understanding the structure of carbon compounds. Key families of carbon compounds are 1. Alkanes. They are saturated hydrocarbons, which means the bonds between a carbon atom and the hydrogen atom are single. General formula for this: CnH2n plus 2. Only single bonds it shows as it is. Examples of alkanes are methane, ethane, propane, butane, etc. The second one, alkenes, unsaturated hydrocarbons. General formula for this is CnH2n. It contains at least one double bond, it shows here. An example for alkene is ethene, C2H4. The third one is alcohols, contain the functional group OH. Example, ethanol, C2H5OH. The fourth one is carboxylic acids, contain the functional group of COOH. Example for carboxylic acid is ethanoic acid, CH3COOH. Functional groups: recognize these in exams for identifying organic molecules. The fifth one, key environmental and practical considerations. Pros of fossil fuels: they have high energy density and they are used in electricity generation, transportation, and as feedstock for chemicals. Cons of fossil fuels: they are non-renewable, so they are limited supply, and they create pollution. Combustion emits greenhouse gases and particulates. Exam tip: be able to suggest alternate energy sources like solar, wind, and biofuels. That's it for today's concise crash course on carbon chemistry. We covered some key exam essentials, from the properties of carbon to combustion and organic molecules. But don't worry, there is more to come. I will be covering all the topics in carbon chemistry in details in upcoming videos. So, stay tuned. If this lesson helped you, please like, share, and subscribe to Target Teach Tutors. And don't forget to hit the bell icon so you never miss an update. Until next time, keep learning and stay confident. Bye for now.